Okay, in section 2 we are going to start talking about solving quadratics, and we'll break section 2 into two parts, and section 3 will also be about solving what's called a quadratic equation. So what is a quadratic equation? A quadratic equation is any equation that can be written as ax squared plus bx plus c equals 0, where a can't be 0. So the key thing here is this square. Anytime you have a square, that's typically very indicative of a quadratic equation. So when you're trying to solve a quadratic, just like any equation, if I have some general quadratic, x squared plus 2x plus 1 equals 0, I'm trying to find what numbers I can put in for x that would make this equation true. For example, I know that x equals -1 is a solution to this because -1 squared plus 2 times -1 plus 1 equals 0, because this is 1 minus 2 plus 1, which is 0. So I'm trying to find these solutions like this one, which I just knew. I'd like to know what the solutions to quadratics are. So for almost every quadratic equation, the good idea is when you're solving a quadratic equation, you want to always make sure you set it equal to 0. So if I have something like this, what I'd first want to do is I'd want to move the 3 by subtracting it and make it x squared plus 5x minus 3 equals 0. So we want to have everything on one side to solve a quadratic, and that's for any of our technique that's what we're going to do. So the first way we're going to solve quadratics is by factoring. Now we do this by factoring by taking advantage of a really simple mathematical theorem, which is called the zero product property. And it simply says if a times b equals 0, then a equals 0 or b equals 0. So if two things multiply to give you 0, then one of them must be 0. This is kind of why we want our quadratics equal to 0, because we can set this, use this property if it's set equal to 0. So here we have a quadratic equation, x squared plus 10x plus 16. Now in this section, we're trying to solve these by factoring. So the first thing I want to make sure is everything is on one side and I have a 0 by itself, which I do. Then I will try to factor the remaining polynomial. Now if you remember how we factor, we use our box. We have x squared, we have 16. We take 1 times 16, which is 16. And we try to find two things that multiply to 16 and add to 10. In this case, that would be positive 8 and positive 2. Those multiply to 16, those add to 10. So I'll put 2x here and 8x here. And then I'll just take common factors out of rows and columns. So I can take an x out here of this first row. And then out of the first column, I can take an x as well. Out of the second column, I can take a 2. And out of the second row, I can take out an 8. So this factors is x plus 2, x plus 8 equals 0. So now this looks almost just like what we have up here, where it says, do we have two things multiplied together equal 0? We do. We have this times this equals 0. So by the product property, zero product property, we can take each of these, x plus 2, set it equal to 0, or x plus 8 equal to 0. And then we just solve those. So I'll subtract 2 here, so x would be -2. I'll subtract 8 here, so x is -8. So these are my two solutions to the quadratic. We can check one just to check if it works. I'll check the -2. I'll check it in my original to see if it works. So I have negative 2 squared plus 10 times negative 2 plus 16. Well, this is 4 minus 20 plus 16. So that's 20 minus 20, which is 0. So that does check, as does negative 8. So you get everything on one side, it factors, and then you set each factor equal to 0. So quadratics, when they factor, if you can factor, are really pretty easy. When these will become difficult in the next couple sections when you can't factor the quadratics but still have to solve them. So let's look at this one. X squared minus 9x equals negative 18. The first thing I'm going to, of course, do is I'm going to add 18 to both sides because I have to get that 0 by itself. So this will be x squared minus 9x plus 18, and I just wrote it in descending order, equals 0. So now I've got everything on one side. I hope it factors, because that's really the way we're doing these. So 1 times 18 is 18. So I want two things that multiply to positive 18 but add to negative 9. So they both have to be negative, obviously, because if it's going to multiply to this positive 18, they both have to be negative, negative, or positive, positive. And it turns out it's 6 and 3. Because negative 6 times negative 3 is positive 18, and negative 6 plus negative 3 is negative 9. So in my box, I've got my x squared, I've got my minus 6x, my minus 3x, and my positive 18. So the first row I'll take out an x, which will make this x. Now out of the first column, I have 6 and 18, which I could take a 6 out, but we said if the first one is negative, we should take that negative out. Same thing for this row. 3 and 18, I can take a 3 out, but if the first one is negative, we should take that out. So my two factors are x minus 6, x minus 3 equals 0. So I'll set both of those factors equal to 0. X minus 6 equals 0, x minus 3 equals 0, and I'll just solve them. So I add 6 so I get 6, I add 3 so I get 3. So these are my two solutions to that quadratic. Okay, let's look at another one. Now, this one we have 3x squared on one side, 11x, and 4 on the other side. I want to get everything on one side. Now, even though there's only one term over here, it's that 3x squared, I'm still going to move everything to the left because when you factor, it's always nice if this first term is positive. Not a necessity. You can do it without that. Just a little harder. So I'm going to subtract 11x and subtract 4. So I can write this as 3x squared minus 11x minus 4 equals 0. So when I factor it with my box, remember the first thing I do is multiply the first and the last term. So 3 times negative 4 is negative 12. So I want things that multiply to negative 12 that add to negative 11. That's pretty easy. That'd be negative 12 and positive 1. So I'll put minus 12x here, and I'll put 1x here. So the first row I can take out a 3 and an x. The first column I can take out just an x. If I do this bottom row, I have 1x and 4. There's really nothing in common there, so let's put a 1. And we have negative 12x and negative 4, which I can take a 4 out. But then I'll make it negative because the first term is negative. So my two factors are 3x plus 1. X minus 4 equals 0. So I set both of those equal to 0. So this would be 3x, I'll subtract 1, so 3x equals negative 1. I'll divide by 3. So x is negative 1/3. Add 4, x is equal to 4. So my solutions are negative 1/3 and 4. Okay, now this is an interesting one, because if you notice, there are only two terms. There's only the 9x squared and the 25. So when you only have two terms, remember our factoring techniques for that. We have the difference of squares, or the difference or sum of cubes, but these are definitely not cubes. Is 9x squared a square? It is, because it's 3x and 3x. Is 25 a square? It is. It's 5 and 5. So this polynomial will factor as 3x plus 5, 3x minus 5. So if I solve these, 3x plus 5 equals 0, 3x minus 5 equals 0. I'll subtract 5, 3x equals negative 5, and then I would divide by 3. So x is negative 5/3. Here I would add 5. So 3x equals 5. Divide by 3. X is equal to 5/3. So negative or positive 5/3. So when you have those two terms, look out for those difference of squares. That happens quite often. Couple more examples. So let's look at this quadratic here. Everything is on one side, which is nice. So I'll go ahead and I'll try to factor it. So I'll multiply the first and the last. I get minus 12. So I'm looking for two things that multiply to minus 12, add to minus 1. So that'd be minus 4 and positive 3. And sometimes this is the hardest thing, trying to figure out what those numbers are that will multiply yet add. So x squared minus 12, minus 4x, and 3x. So I can take an x out of these two. I can take a 3 out of these two. This column I can just take an x. And then I have 4 and 12, which I can take a 4, but then I'll make it negative because the first term is negative. So my factors are x minus 4, x plus 3 equals 0. And so then I'll just set those factors equal to 0. So I'll add 4. So x equals 4. I'll subtract 3. X equals negative 3. Hopefully you start to see the pattern that whatever is the opposite of the number in your parentheses is typically what's going to happen. Now on the previous page, when you had like a 3x, you had to divide the 3, but it still works very similar. All right, our last example also has two terms. Now I put this one on here because a lot of people say, well, I just want to start doing things like taking the square root, which will work, but it actually does not find all your solutions, because if you take the square root, then you get x equals the square root of 100, which is 10. But as I will show you, there's actually another answer. So if I do it the factoring method, I'll subtract 100 from both sides to get everything on one side, to get a 0 on one side. But now this is difference of squares, because this is x and 10 and 10. So this factors is x plus 10, x minus 10 equals 0. Well, now if I set those equal to 0, on the right one, if I add 10, I do get 10, so that was an answer. But if you look over here, when I subtract 10, negative 10 is also an answer. And so if you go up here, negative 10 squared is 100, as is 10 squared. When you do the square root, you do that a lot in geometry and stuff because there is no such thing as negative values, but in algebra we certainly can have them. All right, so that was part 1, solving by factoring. So there is an assignment part 1 that you can try for Module 4, Section 2.